Welcome to day 11 of our distance learning. Countdown is here. We should be back in building Monday. Good thing there for sure. Real quickly, I was misinformed yesterday morning about the Groundhog's Day outcome. Apparently, we have 6 more weeks of winter. It's Oklahoma, so what does that mean? I don't know. Winter apparently means 70 sometimes. So, okay. Anyways, let's move on to what we are actually here for. Coordinate planes and distance between points. That is our expectations to talk about here today. And it'll probably bleed into tomorrow a little bit. You'll see how it goes. And I will see how it goes. So distance between points on the coordinate plane. We're wanting to know what the distance is between any kind of points, whether you're looking at a shape or whether you're just looking at two separate points that exist in the coordinate system. And that's what we're going to talk about here. Now, most important, I have brought this up over and over again, and it still holds true. You need to know your signs for each quadrant. This comes in super handy here with this process because in order to know your signs, it helps you be able to better understand what quadrants it is, which works out for this process. Now, let's talk here. If you are looking at 2 points, for example, here we have point A and point B, we have to do some work. We have to do some investigation. Let's read what it says. Same means substitute or subtract. What does that mean? If 2 coordinate points are in the same quadrant, then you need to subtract the absolute value of the numbers that are different in the coordinate pairs. Why do we have to do absolute value? Well, if they are in the negative world and you do a subtraction with negatives, you know that messes with the number, right? Well, instead of doing that, we want to get the absolute value, since that way you're just basically looking at their distance from 0, right? Obviously. Now, looking at our 2 points. Based on the information we have here, A is at -5, +3. B is at -2, +3. That puts them both into quadrant 2. Good. So, as it tells us, we need to look at the different values in each pair, which means if there are 3, well, what we need to do is get rid of the identical value. We don't need to worry about the y in this situation because they're both 3s of the same thing. That's not going to give us anything. We need to worry about the 5 and the 2. And since we're talking again about absolute value, then it's not -5 and -2 that we're dealing with. It's actually 5 and 2. So 5 minus 2 gives us 3. So our distance between the 2 points is 3. Now, some of you are probably going, well, yeah, I can see that. We have it on the graph. All you got to do is count the lines. That's great. That's helpful. That's another way, obviously, to do it when you have a actual coordinate system to look at for your points. Yes, that's right. That means that there are potentially going to be problems that don't have that. That's why we have to know our process. Okay, again, all about the process of Mr. Greener. Same means subtract. Same quadrant, we subtract the different values, okay? It really barrels down to just that situation. We get rid of whatever identical coordinate is in the 2 pairs, and then we look at just the unique values. We take their absolute values, and if they are in the same quadrant, we subtract, okay? Now, if we are looking at different quadrants, so we have 2 points that are in 2 different quadrants, then we have to do some addition, okay? Here's what happens. So, we have our point A, which is at 3, 1. We have our point B, which is at 3, -5. If they are in different quadrants, 1 and 4, then we add the different values in the ordered pairs. Okay, different means add. So once again, absolute value of the different numbers. We only worry about the 1 and the -5 because 3's for the x's are the exact same value. So we don't want those. That's not going to give us any distance. Just the 1 and the -5 is going to help us. Okay? Different numbers. So get rid of the 3's. Just make sure we understand this. Only worry about the 1 and the -5. Okay. Absolute value means that the absolute value of 1 is, of course, 1. The absolute value of -5 is going to be, of course, just 5. So 1 plus 5, well, that's 6 units. So our distance between these 2 points is actually going to be 6. Again, if they're in different quadrants, we add. On the previous slide, if they're on the same quadrant, we subtract. Well, why do we do that, Mr. Greener? Because if they're in different quadrants, they cross an axis point, which means at some point the numbers reset once they hit that 0, right? So it's going to be that 1 step to the 0, but then we have 5 steps from that 0 to get to the next point. So you have the 1 on one side, the 5 on the other side, that merge together to get you your distance of 6. Okay? So this is a process. This is going to be a lot of practice. This is going to be a lot of, okay, there's a lot of information there. What do I need to do? We're going to work through this, okay? So we have a point A, that's in quadrant 3. We have a point B, that's in quadrant 4. If we're going to find the distance between those 2 points, -4, -3, and +3, -3, what are we going to do? Remember what it said. Different quadrants, we add. Different add, same subtract. Okay, so if they're in the different quadrants as they show us, we have to add those absolute values of the unique numbers. Once again, we are looking at the 2 ordered pairs. What do we see that's the same values? The same values are going to be the y's, right? So we don't need those to worry about. Let's get rid of those out of our process right now. We're just looking at the -4 and the +3. We need absolute values of both of those numbers, okay? So a absolute value of -4 means it's just 4, right? Absolute value of 3 is just 3. So we're adding those 2 numbers together. What's 4 plus 3 going to give us? 7. Distance between 2 points, 7 steps. Once again, I know where some of you were going, but we have the graph right there. We can count. Good. It's because we have the graph, right? That helps. Makes it a lot easier. All right. Now, let's look at another example. A and B this time. What do you know? They're in the same quadrants. Okay. Also, we are looking at a point that is at that same y quadrant or coordinate at -3. So that's going to be our same number that we can ignore. We're looking at -4 and -2 is our 2 in the same quadrant. Same means subtract. So we need the absolute values again. So we have 4 minus 2, right? Absolute value of -4 is 4. Absolute value of -2 is 2. Subtract 4 minus 2 and we get 2 as our value or our distance between those 2 points. Okay. Now, here we go. This is why we were going through the process. What happens if you don't have the coordinates plane to use as a reference, right? Well, we got to rely on our knowledge of the quadrant signs to be able to establish, first off, whether they're in the same quadrant or a different quadrant. Okay? And that, again, very important. Make sure this gets in your notes as well, for sure, because it should be on there already, but if it's not, bammo, I don't know what that means. Here it is again. All right, so let's figure out if the points are in the same quadrant or in different quadrants by looking at the signs of the numbers. If you know your signs and what quadrants they exist in, you're good to go. If you have a 2 and a -3, well, that is a positive and negative, and of course that puts us into quadrant 4. And then we go back to the same basic rules for distance between points. If it's the same quadrant, we subtract. If it's in different quadrants, we add, right? Right. Same subtract, different add. Let's look at a specific example here. We have 9, -3, 9, -11. That is a positive, negative, positive, negative. So that tells us it's in what quadrant? Well, that's what we got to think about. Positive, negative would be quadrant 4. For those that knew that, wonderful. Okay, let's keep going here. What about these? What quadrants are we looking at here? We have a negative, negative, and a negative, negative. Okay, so what quadrant has 2 negatives? If your thoughts told you 3, you're on the right path. Wonderful. Let's keep going. We have a negative and a positive. And then the other one is a positive, positive. So that means that we are looking at, are they in the same quadrants? No, because they're not the same sign patch or pair. Negative, positive, positive, positive means that they're not going to be existing in the same quadrants. Okay? It means we're looking at a cross of an axis between 1 and 2, or 2 and 1, quadrant 2, quadrant 1. Alright. So again, keep thinking about this. Know your signs. Know if your 2 points that you're looking at are going to be in the same quadrants. That's very important. Okay. So, using this example, 9, negative 3, and 9, negative 11. If they're in the same quadrant, that clearly means we subtract the unique values. Unique means not the same. In this one, our same value is going to be that 9. Let's get rid of it. We have negative 3 and we have negative 11. Same means subtract. We need the absolute value of those two numbers. So that means instead of negative 11 and negative 3, it becomes 11 and 3 being subtracted. But what is 11 minus 3? That's right, 8. 8 units. What comes up always is, how do I know which number to put first? Here's the easiest answer to this. Since we're looking at distance, and if we are subtracting, go with the larger value first, right? Because that way it gives you a positive answer after the subtraction. And we don't want to deal with integers because you can't have a negative distance between 2 points. That literally means they have gone into each other in some kind of weird way, or in some kind of negative zone, for my comic nerds, some weird alternate dimension. So you can't have negative distance between points. That has to be a positive distance. Just remember that, please. Don't give me negative answers. It happens. Just don't be that person. Okay. Another example. Negative 3, negative 6, negative 11, negative 6. Okay? Are they in the same quadrants? Yes, they are. Okay? Same means subtract once again. So what is the unique values we're dealing with? What do you know? It's still negative 3 and negative 11, because the y's were the same value. We get rid of those and we subtract. So absolute value means that becomes 11 minus 3 again. And what do you know? The answer is still 8 on this pair's distance. Alright, here we go. Negative and a positive, positive and positive. Are they in the same quadrants? No, they are not. So if they're not, that means that we have to add different quadrants. We add to find the distance. We get rid of the value that is the same in both, and that happens to be our y coordinate at 5. So we're going to remove those two. Get them out of here. Boom. And now we're looking at just the negative 1 and the positive 6. We want their absolute values, and we're going to add those two together. So the absolute value of negative 1 is 1. So 1 plus 6 comes together and gives us 7. We get our distance between those points as 7. Plenty more examples here for you in the notes. Keep the practice going, because it's going to come in handy when it comes to the assignment today. See if I can get this to come up. Okay, so your assignment is actually going into the textbook that we rarely use. I know, right? Here it has made an occurrence for us. We're looking at 2.5 in the textbook, and we're going to go into their practice worksheet for you to do some work. Notice there are no coordinate planes on these top problems, numbers 1 through 8. That means that's what you're dealing with is going to be, like I just showed you, different means add, same means subtract. You have to look at the coordinates to figure out if they're in the same quadrant, and then do the work as it tells you. Obviously, numbers 1 through 4 are actually step-by-step walk you through, so that all you have to do is plug in the proper values, but then from 5 through 8, you're doing it on your own. So I'm not going to do the ones that are already pre-built for you. I mean, what value does that have to you? I'm going to go ahead and do number 3, because I know you guys are going to freak out over the fact that there are mixed numbers here. So I'll give you, not number 3, I'm sorry, number 6. Let's do number 6. Okay, so first things first. We have a positive negative and a positive negative. Does that mean they're in the same or different quadrants? They are in the same quadrant. If they're in the same, that means we're subtracting. Okay, so we know that. Next, what is the same value in both pairs? It's the x. So we don't need those. We'll get rid of the x's. So, if the board decides to catch up, there we go. All we need to worry about is the -6 and the -2.5. We have to subtract those. I'm going to go over the chalkboard here so I don't have to wait on it. Absolute value of -6 minus the absolute value of -2.5. Okay, so we are looking at 6 minus 2.5. We would like to, I would like you to, convert, obviously, to make this an easier problem to solve. 6 as a fraction would become 6/1, right? So we would want to get a common denominator to be able to subtract these. Well, if you have a 1 and a 2, guess what your common denominator is going to be? It's going to be 2. Right? So 1 times 2 gives us 2. So what is 6 times 2 going to give us? 12. In this one, I'm going to do a conversion from a mixed to an improper. So we're going to go ahead and do that. 2 times 2 is 4. 4 plus 1 is 5. 5. We are not converting that because it's already got 2 as a denominator. So we're looking at a 12 minus 5. Both of these over 2, which is why I just put a one single denominator here. That's going to give us 7/2, which is improper. Let's convert that back into a mixed number. 2 into 7. How many times? You're right. 3. What's left? 1. Squeaky chalk today. Okay, so that was number 6. Just gave you the actual process, the work that you need to show and do for number 6. I know you're doing this stuff virtually, so it's going to be a little trickier, but if you want to do it on a piece of paper and take a snapshot and email that to me, go for it. If you want to show me your work on the paper through the digital process, doing some texting, add the text to the page, do that, whatever. But I want to make sure you're understanding what you're doing here to get your answers. Again, absolute value of the different values. This one had a fraction, so we had to do some converting. Once we got there, we converted it back, and we got our distance, 3.5. This is a longer video than normal, I know. But that's because it's a process that is brand new, and it's going to take some work. You're doing the entire page. Oops. You're doing the entire page today. So make sure you pay attention to the bottom. Yes, there's a graph on that one to help you along, hopefully. But this entire page is your responsibility, 1 through 12. Okay? Do it, ask questions, get it turned in, we'll be good to go, right? Perfect. Okay. We'll catch, today's Wednesday, right? So I have first and third hour as my Google Meet, so I'll catch you guys at 10 and 11 to further explain this. So I know there's going to be confused looks on your faces. We'll deal with it then. The rest of you, I'll catch you tomorrow on Google Meets, and we'll talk about this some more. Okay? Get it in your notes, get the assignment done, get the help out of the textbook if you need it. You should have your textbook home with you, and we'll be happy. Well, you'll be happy. I'll be happy because I'll have great grades to put in your grade book. Have a great midweek Wednesday. Catch you tomorrow.